See, I'm having two switches over here. Okay, and one is configured with the MTU 9000 and another switch is configured with the MTU 1500. So when the traffic from the switch configured with 9000 is moved to the switch which is configured with an MTU of 1500, that time, like when it hits that the traffic hits that switch which is configured with 1500, that packet will get dropped. Okay, that is the reason uh, it has been told that we need to ensure that MTU size has been configured evenly in all the network devices from 1000 default to 9000. So we need to ensure before VxRail deployment. Okay, so next key phase we are going to move now. So plan and prepare VxRail implementation in your data center before product delivery. So we are going to we completed the phase 2 now, because we discussed a lot of things, right? So we discussed about data center network completed, then topology, data center network as completed. Now we move to topology and connections, because from networking perspective, we need to prepare a network topology diagram, and we need to ensure how the devices will be interconnected from the rack to the network devices. Okay, so that needs to be diagrammed. Like we need to prepare a topology diagram before the VxRail deployment. So this is an example from the server, how the connectivity will goes to the spine switch, from spine switch, how it will goes to the from the leaf switch, how it goes to the spine switch. This is an example of that. Okay, let's combining of two ports to act as a single port logically. Okay, so we can reduce the downtime, that is called as resilience here. So there is the risk of downtime has been reduced due to this port channel. Then we can get increased bandwidth. For example, I'm in a single port, I'm able to allow up to 10 Gbps. When we combine two ports together using this port channel, what would happen? Thus 10 Gbps physical will be logically converted to 20 Gbps, because each physical NIC is each physical port is having 10 Gbps bandwidth capacity. I'm just combining two physical ports. So that time what is happening? 10 plus 10, I'm just saying for example, okay, 10 plus 10, it is changing to 20 Gbps logically. So increased bandwidth. Then next one is simplified network topology. Okay, so we can maintain a loop-free topology by using this port channel. These are the advantages. And before we close for today, let's understand one more thing, like port channel and ether channel. So, like in when we work with the network team, sometimes they will say this is a port channel. Port channel means we already have like combining two ports to act as a single port logically. Sometimes, like people in the call in the meeting, they will say that ether channel. So port channel and ether channel both are same. Okay, and ether channel is a concept which has been used in the Cisco devices, and rest of the other third-party devices, the name which is given for combining two ports to work as a single logical port is port channel. But concept remains same. Only thing is this ether channel name is a Cisco proprietary name for link aggregation. As I told you, right, for LACP protocol, most of the third-party vendors use LACP as the protocol for using link aggregation group. But for Cisco devices, the protocol used over there is PAGP, because that is Cisco proprietary. The same way, this port channel and ether channel will do the same functionality, but the name ether channel is a Cisco proprietary name for link aggregation. Okay. Okay, so we'll stop here today. So if you have any doubts, you can ask me on the network part. I'll try to get that network document to configure VLTA. Okay, so that you can go through the document, because that will have more steps. If you have time, you can